who to give the credit to, right? So say for example, you use Mickey Mouse as your account, and I look at the README, nothing there. I look at your project, nothing there, and then there's really no way for me to figure out who that belongs to. And then when I grade it and give you, scores, I won't know who should give the score to. So I really would like you to make sure that your name is, is somehow I can, some can indicate to me that who this belong to, right? Even if you have part of your name, that's fine. Part of your last name, or preferably not part of your first name, because that's harder. Okay, but I went through. I look at the roster and then try to figure out, who's Mickey Mouse, and then I had a lot of difficulty doing that. So last time what I said was, if you want to use such a name, which is okay. However, I would ask you to kind of indicating who you are on the README file. So put down your name, at least for this course. So this way I know who this is. Okay. I have something very, very strange names, and I just couldn't figure it out. All right. If you are, again, then how many people know 23? If you think there's no way someone can tell by looking at your repository or look at your account name, would you please go to README file, make sure you add your name, your real name in there? Okay, could you do that? And then make a commit. So this way, we know you did this after this deadline, which is fine. There's no penalty for that. Okay. But don't add anything other than that, right? Don't submit your project late, because we're already very late. By the way, this is the middle point of the semester, so we got a lot of other things to cover. So we cannot keep on going back and delay the deadline. Okay. So that's one thing. Okay. Another thing is when you present your data, right? Okay, I got a couple more people coming. I think 24. The two more people. Okay, when you present your data, right? When you do your test to figure out what's the right data structure to use. Now, if your data is all like zeros or ones, that won't tell the difference. That means you say you did 20 or 10 tests. Okay, different sample size, different size, different data structure size, and then they all get a result of 0. Okay, that may appear to be great. Okay, but that may not be good enough, because you cannot tell the difference. You understand? You need some kind of way you can tell which one's slower, which one's faster, right? Whether it grows or not as the problem size increases. Okay, if it's all 0 or 1, that tells you that especially all 0, that tells you that the unit of the time may be too big. Say if you use hour, okay, or minutes even to test the data set, they're all within a minute, right, or a fraction of a minute, in fact. So you will get all 0. Okay, when you plot it out, it's gonna be all 0. Then obviously, that's not informative enough. Okay, you can just imagine this, exaggerate this. You think, okay, what if I make the unit is an hour? It doesn't matter how big the problem is. It's going to be all under an hour, so it's going to be all 0. So you will get, when you look at this, no change, right? It's all 0. Then you will conclude that the big O is 1, because it's a constant. It's all 0. But that doesn't mean anything, right? That doesn't mean anything. That's not sensitive enough, okay, to tell the difference. So I saw some of you with the result all 0, and you probably should think about it. Say, is it possible, right? Given the data structure, say a linked list or a tree, either you get a log n roughly, right, and or n if you're linked list, right? You already have that understanding, I think. Then when you get all 0, your conclusion is this is 1. The big O is 1. Then you should at least think about it. Is it right? Is it possible, to have all these data structures all have a big O of 1, right? So you really should doubt and then just use common sense. You say, okay, my linked list is 1,000 is 0, 1,000,000 is 0. Isn't it possible that something's wrong here? Okay, that data doesn't mean anything in that case. Okay, so that should be obvious. That should be obvious. So if you get that, that means that's the time unit, okay, is not sensitive enough to tell the difference. So you may have to make the unit smaller, right? If a millisecond is not good enough, then you may have to use a nanosecond. Nanoseconds should be sensitive enough to the kind of work you're doing. Okay, unless you have really a supercomputer at home, it does everything so fast, and then even nanosecond is not small enough. All right. So, do you understand? Do you understand what I'm talking about? Does that make sense? Right? It makes sense, right? So, so I hope you understand that. Okay. Then another thing is when I read your discussions. Okay, I understand you don't want to write in the way I suggested because that's kind of more formal, right? Um, but at least write something, okay? Don't just write a couple sentence. Don't just describe the big O's for different data structures because that's not the point. That's not the discussion. That's not the focus of the discussion. I see some of you will just list for a tree, big O is log n, for linked list, big O is n, and focus on that. That's not the focus of this. That's not the purpose of this project. The project is for the kind of data types we have, trails, users, and history. What is the actual performance when you increase the size of the problem? Okay, it's not just generally is n or log n or 1. It's not just that. It's really testing, confirming, provide evidence to support the claim you're making. Okay, so you need to actually do some calculation, put general data, put into the structure, do some operation like a search or insertion or deletion, whatever. Then you have to see actual data. Don't give me a general conclusion saying tree is log n, linked list is n, map, hash map is 1. We know that, right? We know that. By the way, there's another thing. Remember I said evidence-based is something you need to always keep in mind. Another thing is don't write anything unless you are contributing something new. Okay, so when you say something, right? When you write something, um, you have to have some new things added to it, right? You have some original data, original conclusion. You have to have something to contribute. I know when you are young, you are high school, maybe I guess in college, a lot of time you spend regurgitating what we read from the book, right? Which is understandable, but just for the future, when you are getting older, when you are in the workplace. There's really no reason to write anything that is well known or accepted. Okay, that because that has no value to it. You understand? When you write something, ideally it should have value to it. What's the trouble? Okay. Otherwise, why people want to read, what you write if they can read elsewhere? You understand? So when you make a contribution, something has to be original. Like in this case, given the trails, given the data sets you generated, what is the time? That's the actual time spent to do a insertion or search or deletion. That's new. Nobody ever did that, right? Because nobody ever thought about using trails with this kind of data set to try it out. And that's original. That's worth reading, right? People will be, I think a lot of people would be fascinated to read about it and see what the result is. But on the other hand, if you just tell people, a tree is log n, a linked list is n, people will say, why am I reading this? Right? Why you want to write about it? Because that's the well-known fact. Right? So I think that's just another point. The whole thing in life, just a few such points you need to know. This is the second one. The first one was you need the evidence to support the argument. Second one is you need something original to say. Otherwise, just keep quiet. Otherwise, you're just wasting your time, right? Does it make sense? So when you write something, just we already know in your discussion, I will feel like why you're doing this, right? Should I give you credit for that or should not? Because it's nothing that's from you, right? Because that's just something well known, well accepted. You just kind of copy pasted it. So if in the workplace, other people will give you no credit, right? Because you have no contribution. Yes. So I hope you understand it. So when you write discussion, you should have something to say. Don't just repeat it. These are things I didn't even think of, so that's why I didn't mention last time. When you submit it, when you read it, I see you're copy and paste the same thing. Then I felt like I need to mention it, so this way, hopefully, in the future. Okay. Okay. Now, since we're done, this is the deadline. Do you have any questions? Okay, so when you submit it, right, both submit onto the GitHub and as well as on the Dropbox on Blackboard. Okay, the school wants to have a copy on Blackboard. In fact, I don't think they like you submit anything onto onto GitHub because they believe they may violate some kind of law, right? They believe that everything we do in class should stay in class. And but I don't agree with that because it's a programming, it's code, and it's good for your future to have such a repository or have such a account. So maybe I violate the school policy by asking to do it. That's why I let you to choose whether you want to use your name or use something else. But I just somehow need to know who that belongs to. Okay. I think you're not going to write anything like confidential, your personal privacy stuff, right? So I think it's okay, right? So if you do have concerns, you let me know, and then of course I would say okay, right? If you worry about privacy, okay. The school in principle, there's a law saying that what we do in class should stay in class. Your performance should never be known to the outside world. Okay, even though I said you make the repositories private, right? So in theory, it's safe, but you never know, right? People could hack into it and whatever, because you use a password that's not very secure. But in any event, do it if you don't feel like this is a privacy issue because you only put in code in there, not any personal information in there. Otherwise, just let me know, and then I definitely will respect that and then not requiring you to do it. But I thought it's just a good exercise to have an account and then set a table for future projects, in your career. All right, that's all I have to say. Do you have any questions before we move on to the second phase?
Just one quick question. So this morning we were supposed to submit everything, right?
Oh my, that's a scary question.
I just
Okay.
want to make sure because like if I can edit
That
something,
sounds good.
I'll edit it.
Okay.
Like I submitted it, but if I can edit,
great.
like can I still edit it?
No,
All right.
you can do study edit it, because you can commit history tells me when you stop.
Wait, so when do we stop? That's all I'm asking.
You can keep on working on it, but I will grade up to this 12:30 today.
Oh, okay. Now I got you.
Because the commit history,
There's a timestamp on it, right?
right? Because
Right.
every commit has the timestamp exactly.
All right. So yeah, never mind. I'm fine.
Okay. Brian. Okay, thank you. Okay, any other questions?
Yeah, I actually have a question, but it's about the like the full project itself.
Mm-hmm.
And that's the part where you said that each trail is going to have stops in them,
Mm-hmm.
and that they'll have intersections and stuff like that. I actually don't think I understand what you mean by that.
Okay.
Like, do you have something that I could
That's
reference?
fine. You don't have to do it at this point. We will go to do it as we go. Okay, we're going to do it together as we go. That part, because that part involves graphs. So at some point, we're going to talk about graphs. We're going to talk about Maven. At that point, we're going to talk about third-party libraries, and then we're going to incorporate that part. Okay, but if you want to go ahead, you could do it already. You can read upon and try to incorporate it. But I don't require you to do it. But the point is, you're gonna have to, for each trail, I asked you to generate some points, okay, or intersections, and then the points or stops, whatever you want to call it, and then that has neighboring points. So in other words, this is like a T or this is a fork. So you have multiple other places you can go from that point, right? So in other words, those points we call neighboring points. Okay, so you're gonna store your information for each point. So let's say the starting point goes to the A, goes to B, B goes to there's a fork. So let me see if I can draw this. Okay, so I'm just randomly pick a place. Let me share my screen. Okay, so this is your A. Okay, that's a point A, and then you go to B, right? And B has a fork or has a T, so you go to a C, and then there's a D, right? D may has its own, right? So this is D, this is C. C keep on going, then you can just a C, or you have a F, and then you breaks, and then there's the F, there's E, okay, or E, F, G, so on and so forth. So as far as F is concerned, there are three neighboring points. There's a C, there's a E, there's a G, right? That's for F. For C, there are two neighboring points, B and F. Can you see that? Can you see that?
I
Right?
have to fake react. I think I
Okay.
have to watch it by
So
myself
for
off
D,
stream.
there are
Then I
B
have
as
to
a
show it on
neighboring
stream.
point, and
I
then
have
there's
to,
another
right?
one here. There's another one. There's
Well, as a
another
mod,
one
do I have a
here.
mod here? Wants to go through.
Okay. So
watch
for
it
each
first?
point, you have neighboring points, right? A neighboring point is B. B has a neighboring point is A and C and D. And D has a B and this one, this one, this one, right? You got it? So with that information, you can travel, say, eventually this gets merged, okay, into here. I don't know. This is M, say, okay? And M will go into here, and then you say this is Z. Okay, so in order to get to Z, you could travel either this way, right? Or you can travel this way, right? You see, so now if you want to go from A to Z, the program will present the two ways to get there, right? You can see that the two ways to get there, and also will calculate how far each way is, because then each there's a distance between neighboring points. So this is 5 miles, this is 3 miles, this is 2 miles. You get an idea, right? So so this way you can calculate what's the total distance for to the two different paths, and then you also can get what's the shortest path.
So are
Okay.
we gonna be doing Pathfinder algorithms?
We're going to do this later, not now. So I don't require you to do this for this project, for this submission at least.
All right.
Brian, you okay? Somebody's yelling in the background.
Yeah, no, I have a bunch of people in my room right now.
Okay.
So
As long as nobody's going to kill you or something.
no, they're just studying too.
Okay. Okay, fine. Because I heard somebody's yelling in the background, so I don't want you to be in any kind of danger or something. Okay, so we don't need to do this now, but this is the idea I want you, because ultimately, for each trail, you're gonna have a collection of points, and each point will have bunch of neighboring points. Okay, some will have two neighboring points, some will have one. Like A has one neighboring point is B, right? And the Z has one, may have two, may have three, but at least one. That's how you can get there. Otherwise, it's going to be an island, right? Okay, so this is what we're going to worry about in the future, but you don't have to worry about now. Is that good? Is that okay, Ryan? Okay. Any other questions? This is something. This is something. This is a topic required to do. Let me see. USACO. Ever heard of this? Probably you never heard of this. USACO, United States of America Olympic. No, Computer Science Olympics. Every country, not every country, many countries will send their delegates to such a competition, computer science Olympics competition. And this is a topic called a graph. And then that is included in the topic for that exam, for that kind of what they call some kind of competition. So yesterday, a couple of kids from Nassau Community College, not no, Nassau County, some high schools, they came to me saying they would like to get a tutor, they would like to compete in the USACO, but I don't have the time. But I said, if any of you guys, I said, I will ask my students, if any of you guys interested and study on the topic, they are willing to pay $70 an hour each kid to get a tutor. So I think there's money to be made if you don't mind teaching, and use that $70 to as incentive to study the topic yourself, including other Java topics we studied so far. I think that's the only one. I think that's probably the only topic we haven't covered on that Olympic, because it's a high school competition. Okay, so kids from all from high schools from many countries. Right, so there's money to be made if you're interested, and then you're willing to put in effort to study the topic. I will. They are still waiting for me to get back to them, because I told them, I don't know. I will ask my students, because definitely I don't have time to tutor them, the high school kids. All right. So, any other questions? I have some other students who want tutor too. So if you want to make a few bucks, let me know. So, no other questions?
So what type of data structure did you say would implement this path?
Graph.
You said again,
The
regular graph.
Yeah, we haven't talked about this yet. So we'll see if you guys are up for it, because I don't know. We still have so much to cover, so we'll go. Hopefully, you guys will follow the deadlines as we go. Now, the next deadline is next week, next Monday. Okay. So it's gonna be the content we're gonna cover today and tomorrow and Wednesday. Okay. So I hope you keep up, and then now update your GitHub as we go. So eventually we'll finish a project with all the aspects. Other questions? No? Okay. So we're gonna start a new topic. We finished talking about the using GitHub, right? So I know many of you were not here last Wednesday, but I think Nick recorded it. So if you want to watch it or do some research on your own how to use GitHub, it's not going to be on the test or anything, but you will reflect on your repository, like a number of commits and the spread out of commits. So when I grade you in the future, I would see you have a bunch of commits, not just like one commit. Okay, one commit is bad. That means you're not really using it. You're doing everything locally. You're not making backup. Then you just when the deadline's due, just push everything end of the semester. That's not what I want. I want you spread out the work into phases, stages. As you make improvement on your project, as you add new material, then you will make new commits. Okay, so we have a commit history recorded in there. You okay with that? So this way you learn how to use GitHub, right? And use Git. Okay, not just the one big commit. Okay. Now today we're gonna talk about the very first thing we need to do when we design an application. Okay, so don't think your applications are finished, right? All we did so far is to evaluate what we're going to use to store the data, what data structures we're going to use the data. We haven't really designed the project really, okay? The goal so far is not how pretty your project is, because you're not done yet. You haven't started yet. So then we just evaluate the data structure to use, right? So that's why there's no GUI needed. Now, the second phase is still no coding, okay? This phase, still no coding. This phase just require you to have a PDF file, okay, to present how many classes you're gonna need, and how classes interact with each other. Okay, so this phase is how many classes you're gonna need for this application. Okay, knowing that you're gonna use the data structure you decide to use, right? Then how many classes you're gonna have in each class? How many instance variables? If there's any static variables, what are they? And then also what methods you need. And when you have methods, what parameters you need, and also what data is going to return. Okay, so you don't lay out all the classes you think you need without actually writing the classes. And also lay out what methods you need without lay out write the methods. It's all on PDF, so there's no need to go on Eclipse to write the code. There's no code, no coding this part. Okay, it's just what are the components of your project without any coding at all. Do you understand? Okay, no coding. Okay, no coding. So we're gonna unlearn a lot of things we learned before. Before in 148, 218, the first thing you do is to turn on start up Eclipse, turn on the computer, start Eclipse, start coding. Okay, now no coding. Okay, we're gonna unlearn all that. Okay, instead, we're gonna put on piece of paper what are the classes we need, what are methods we need, what are variables we need, and most importantly, how different classes is going to interact. Okay, in other words, how they're going to associate with each other, how these different classes methods are going to associate with each other. You understand? In other words, what are the relationships between those classes and where they're going to intersect? Like a user, like trails, where they're going to intersect, how is going to interact, and history, how they're going to intersect with users, how going to intersect with the trails, right? So here you can think about this. These are the users, right? The user profile, and you have the trails, right? Trails, and then you have a bunch of history, right? Like the trail, like a hiking history, okay, for each user. So you're gonna have to decide how they're going to interact. Okay, so first of all, of course, you would think, okay, each user should have a history, correct? Right? Because history, if you think about it, associated with each user. Okay, but also you have to think about the history also somehow associated with this trail, right? Well, not each trail, but with the trail in general, because the history contains the trail the person hiked. Okay, so now you have to decide what part of the trail is going to interact with the history. Right now, when you talk about a user has history, right? Each user has history as soon as you start the one hike. Then you have to think what part of the history should be part of the user, should be incorporated with the user. Right? Should you have all the trails that the person walked incorporated with the user, or something different? If you think about it, right? Because there are lots of trails, right? There are lots of trails. And then the history will have certain trails, like these ones I kind of bolded, okay? Like this one, this one, this one. Okay, should you get everything about a trail and put into the history? Right, that's one option, right? In other words, the trail name, the distance, or the points I just mentioned, the neighboring points, right? And the elevation gains and say the address of the trailhead. Do you want to put every piece of information about the trail into the history? Right? Obviously, that is an option that you can do, right? So that means the history will contain trail objects, right? and plus the date the person hiked that trail, correct? And then that should be in order. So the earlier ones will come first, and then so on and so forth, correct? So it's gonna be ordered. So that's one option, correct? But another option is I'm not going to put all the trail of the entire object into the history. Instead, I will just put an ID of the trail, and the ID will uniquely identify that trail. Then once I know the ID, I know which trail you're talking about. When you need the details, I can use the ID to search the trail's data structure to find the rest of the information about the trail. You see that? So that's another way, right? So there are many ways you can do it. Okay. Then you can also just say, okay, I want the ID. I also want a few things that most likely the user will need to know, such as maybe the address, the name of the trail, rather than everything else. So this way, when the user display the history, the information is right there. It's in the history, right? It shows the name, it shows the date. But if you want the details about the trail, then I will use the ID to search the trail database to find the rest. So that's another option. Some kind of a middle ground, right? Middle ground, right? Because one option is everything is on history. Everything about the trail is on history. That's one solution, correct? Another solution is just the minimalist. I just put the ID and the date on the history, the trail ID. That's what I meant, right? And that's a minimalist. Because if you need anything, you need the trail name, I have used the ID, go to the search for the trail, right? So every time when you want to display the history, I have to go to the trail data structure to find the trail, find the name. If you just want to display which trails you walked or you hiked, then you have to use the ID to search. So you're going to do a lot of search. If you do a lot of trails, you're going to have a bunch of IDs. You have to do a lot of search, correct? And every search will take some time. How much time? Log n. If you do a lot of them, it's going to be n log n, correct? But if you have a middle ground, that means you have the date, you have the ID of the trails, but also have some things that you would normally display in history, like the name of the trail, the date of the trail, then that information may want to be included in history directly. So when you want to display the information is right there, you can just display. You do not have to go find in the data structure again, right? Because it's already there. So you don't have to do that, the search using the ID. But if you want to go to detail and like a button, you click on details about the trail, then use the ID and go find the rest of the information from the trail's data structure. Yes? So that is just one, one way of storing the data, right? How to interact. And the same thing with the history and the user. The user has a history, yes, for sure, right? Yes. Now, what do you want to store the history? That's another thing. Should I have one ID for each entry? Right? So you see, you have this structure to store all the history, right? I think most of you decided to use a linked list because that allows you to expand, also allows you to keep the order, right? Right? Now you can say, hey, can I should the user has a whole history object that contains whatever in a all the history events, or should I just have a linked list that contains a history ID? In other words, every history has a unique ID. That ID goes to the user into a linked list. The linked list is just like a string linked list. of a string. And each string just the ID or integer, whatever, that stores the history of the hikes it takes, the person took. Right? So that would be the minimalist. It just has the ID of a linked list of the IDs of the history events or the hike events. Okay, right? Okay, now how about the trail and the user? How would they interact? Of course, the user will allow you to log in. Once you log in, then you need to be able to search the trails, right? That's the whole point. So you're going to search by name, search by the type, the category. So you need to somehow allow the user to access trail, right? The trails data structure. So people can search. Okay, so when they search, they want to search by trail name, for example, fine. And they search by trail name. When they search by trail name, then what should the trail data structure return? Okay, you, of course, when you just search by name, if you just want to look for names, it will return names, right? All the names matches that keyword. Say you type Long Island green, then the whole bunch of trail names with the Long Island green will show up, right? And then we'll pick one. When you pick one, then that one will return maybe the ID of the trail. Then once you have the ID of the trail, then you could search for the rest of the information, or you can just return the trail as an object. Okay, so those are decisions you have to make. And also people may want to search not by name, by elevation gains. They want to hike the toughest hikes, right? There's a saying like, you hike your own hikes. So you pick the one you want to hike, and then you based on elevation gains or based on the type, because you're one person, you hike a solo, and you want the hike type to be a loop. You're coming back to where you parked your car, right? So so you can search that type. Okay, so you want to be very flexible, maybe. So when you search, you allow people to search by different things. So again, that you need to express yourself when you design the program, what you want people to search by, right? Okay, so anyway, so they all interact. In this case, it's like a triangle, you can see, right? Trails interact with the user interacted with the trails, and so on and so forth. And the trail is interacted with the history interacted with the users. Okay, now sometimes it's one direction, sometimes it's both directional. Now, users will search for data structure. Users will also user will enter trails too. Don't forget that, right? Not just by searching. So there's another type of user. This is a special type we call admins, maybe administrators. So that's a type of user. It's a special type of user. Right now, you don't think maybe I can use a sub class there, because admin is also user, because admins, they hike themselves too. Right, so they not only can search for trails, but also not only they have a history as well, they have a hiking history as well, but also they have some privilege that the regular users don't, which is they are allowed to enter new trails, also to edit, to modify existing trails. So now things get a little bit more complicated, right? Because you're introducing some functionality we never talked about before. But that's reasonable to have, right? Okay, so in this case, it looks like the direction is, users, admins, they use, the word is use, okay, use trails. So admins, users use trails. And admins then also manage trails. But that's just one directional, right? Is one directional. That means users manage trails. So subject is user, or subject is admin, right? They either manage or they both use. That means only admin manage, but both admin and the user use trails. So that's one directional. You don't have the other direction. In other words, you don't have like a trails use users. Trails are not, in fact, they're not even aware of users. Right? It doesn't matter who you are. Trails object contains no information about users. The deaf, tone deaf to users, so to speak. You understand? So that's one directional. But there are some other cases that can be both directional. Okay, but not in this case. Not in this case. Okay, so there are some relationship there. One is manage, one is use. Okay, it's one directional. Okay, and then the user, it's getting so messy. I know it's getting so messy. Okay, the user has a history. So that relationship is different. It has, it owns, has, owns history, right? Each user owns a history that records all the hikes the user did. Now that including admins. Yes, it makes sense, right? Owns. Now, when you say owns, when you say has, you may recall I talked about a kind of relationship in 148 or even maybe 218, maybe. It's called a has a relationship. You remember that? Some of you may remember has a relationship. Like a college has a collection of students, right? A student has a name and so on and so forth, right? Has certain things, has a collection of courses, right? Student has an address. So that's called a has a relationship, right? Okay. Now, in this case, is kind of interesting because if you if the user gets deleted, if the user account gets deleted, and put it more bluntly, if the user died, right, then the history has no meaning to its own right, in its own right, right? Do you understand? Because if there's no user, then there's no history. Right? There's no more user. There's no point to keep a history because the history is part of the user, so to speak, right? It's a part of the user. So that relationship is even more interesting. Is that kind of relationship is more direct, more tight than something like user has an address. Okay, say you have an address, you live in an apartment building. It has an address, right? So if the user don't live there anymore, the address can still be there because some other users may still live there, right? So you cannot destroy the address. You got it? So that relationship is less tight, right? You can remove one without you do remove the other one. But this particular case is not the case. If you remove the user, then you have to remove the history because the history has no place to attach to. Right? The relationship is called owns. It's a part of it, right? Okay, it's like people often use this awful example. I don't think it is pretty. That is, you have as a human, right? you have a head. So if you want to model and had hands and legs, feet, and so on and so forth, right? Now, when you try to model a human, say you want to build a human, say for the sake of building a game, you know, you have like heroes, suppose they're humans. Then when you try to build such an object, you don't just build a human object. It's really human objects made of heads, one head and two legs and 2 feet and hands and so on and so forth, right? So that is different level of abstraction. You got it? So that means a person, a hero, owns a head, 2 feet, 2 hands, 2 arms, 2 legs, so on and so forth, right? So now, if somehow this hero gets killed, dies, all those components have no reason to exist anymore, right? That hero's legs shouldn't be there anymore. The head should not, that as an object. I'm talking about object, you understand, right? It's not a real life. So those has no rights in its own right to exist. So they should be all killed, in other words. So that relationship is different. The other relationship is maybe the hero has a gun or has a vehicle, and when the hero gets killed, the gun, the vehicle can still be used by other heroes, by other people, by other actors. Because that relationship is still has a, but the has a is not so tight. It's not like exclusively owned by this particular hero. You understand? So those are things that are going to be coded differently. If you think about it, when you code it, you probably never thought about it, right? You think about it, you have to code them differently. Why? Because the lifeline, the lifetime is different. When you create a person, you have to create a head and legs and the feet in that as you create that person. So the life of a head is associated with that person, specifically with that person. So you kill that person, the heads get killed. But when you create a rifle or a pistol, when you want to be used by a hero and the weapon that a rifle can be reused, so you do not want to create a rifle or create a pistol with that user, with that hero. So you want to create a rifle outside of the hero. So when the hero gets killed, the rifle life still there, can be reused. So that means the creation of a different object should have a different time, that should have a different lifespan. When they're created, when get destroyed, there's all factors you have to take into consideration when you write the code. Does that make a little bit of sense to you? Yeah? Right? So those are things like that's just something that you know, if we just put open Eclipse, start writing code, we probably will never think about this. We just write it out, and as long as it works, and then you realize, you know, it's a bad idea. Then you go back and rewrite the code. That's what happened in 148. You have no idea how many people were struggling 148 because they're gonna write and then realize this is a dead end and this is not what works out. Then you have to rewrite, right? That's make 148 such a awful course. They got a lot of people drop out of 148 because they could not take this, right? That's meant to be that way so we can weed out people. That just runs a natural course. Now, now at this stage, you understand that when you write a code, it's not just go on Eclipse and write it. Is to think about it, think through all the things like this I just mentioned. Yes? Okay. Now, give you a more real life example. If I pen. So remember we used to write a lot of back class, right? When we write a back class, usually we have an insert method, right? And the insert method, you have options. You could add like a name or say you want to have a person back, say P back, right? So you put a string name, then you put the say the address, then you're going to create a person object inside the insert method. Then you insert that, right? You create a new person, and then put the name and whatever information. So now you see this. This object is created inside the insert method, the person object, with the student or instructor, whatever you want, right? So, and then you insert that person into the bag, correct? So if you destroy the person, you destroy the bag, I mean, so the bag dies, then all the content will die, correct? Because those object is created inside here. The lifeline is inside. But on the other hand, if you create a person, when you insert, you say person, and that person comes into the insert from outside. That means the person is created outside of the bag class. Say in the demo. Okay, then that person is not destroyed when you destroy the bag. Can you see that? The person still be in demo, can still be do other things, even if you don't have a bag. Can you see it? So those are different implementations. In 148, you don't care, right? Because as long as you can hold a person, but now you have to care. Do I need that person object even if I don't have the bag class? So where should I create a person object? When the creation should occur? What is the lifeline? When should I destroy the person object? So all the things should be considered. Yes? Make sense? Now, the way I present it, use alive or born or killed or dead or die. You notice I use a lot of those things. That's because there's a third things you need to know about life lessons. The first one was, remember, was you need use evidence, right? Second thing is you have to have something original to say it, right? Third thing is never underestimate the power of storytelling. Doesn't matter what you study, because that's how we are evolved. We are selected as humans. Storytelling. That's how we convey knowledge or convey emotions. You understand? So I'm just throw this out. I'm not going to elaborate on this, but I'm just going to do some research to find out how powerful storytelling is, because that the whole idea is embedded deeply in our human mind. Okay, when you organize your knowledge, when you think about things, say you want to be creative, you want to be more compelling or more powerful, and one of the things you can do, the most powerful thing I argue, is storytelling. Okay, you think about it, all the brands you know about, right? You know, Marlboro, the cigarettes, if you smoke, you know that cowboy, and that's presenting a story. When you look at the image, there's a story behind it, right? It creates some kind of emotion. It's not accident. They have that. It's all a game. It's all by design. Okay, it is true. I know, Ryan, you're smiling. It is all true. It's all true. Nothing is an accident. Okay, if you think about everything in life. Okay, anyway, I'm not going to elaborate on that. So the best way to present something, okay, to connect with the person, is through storytelling. Okay, if you think about how you learn things when you're little, You learn a lot of stories. You remember a lot of stories, right? That's the foundation of our knowledge. That's all those reference points. When we learn things, we need reference points, right? Things we know for sure this is right, this is correct, we feel comfortable with, right? All those things are built surrounding stories. So, so I think that's something, you know, when you want to convince people, when you want to say things, the best way to do it is through telling some stories. So that's why literature is based on, okay, friction is based on. That's how people can connect. But if you have platitudes, just have slogans, and that's hard to connect. Okay, all right. So that's why I use all those things like when it's born, when it's killed, because you can easily relate. When it dies, you can easily relate. It's like a history. It's like a lifeline. Okay, all right. So I just give you this introduction, and then we're gonna show you how you actually do it, right? How you actually do it. Okay, eventually that's your next assignment. You're going to present your design in a way we call a standard way. It turns out UML diagrams. UML, Unified Modeling Language. That's what it stands for. Unified Modeling Language. Okay, UML. That's used not just in programming, but in business, in a lot of applications. UML diagram. So my next assignment is do UML diagram to show the design of this application. In other words, without writing a line of code, design the first, put it down into a diagram or two diagrams specifically, and then so everybody who see your diagram will understand how you're going to implement it and what this program is about without reading a line of code. So a person without any knowledge of Java can understand what this program is about, what are the components, and then if a program sees it, the programmer can go ahead and implement it without talking to you at all. So that's the power of UML diagrams. You present how you want the program to be designed. You present how the program can do, what the program can do in two diagrams. Then the actual developers will be able to develop the application without talking to you at all, because everything is in the diagram. Do you understand that? Any question? So that's our goal, right? We need two diagrams. There are tens of different diagrams to choose from, but I just want you to get a taste of it. Do two diagrams. One's called, let me write this down, then we'll go there, okay? Use case diagram. That's the first one. The second one is called class diagram. Okay, so these are the two I want you to do. Okay, now use case diagram defines what this application does. Okay, it puts down a wall, okay, to define what this program does inside the wall and what program doesn't do or some other program should do outside the wall. So this way you know exactly what this program is supposed to do. What's the responsibility of the program? Other things that's related, but it's not the responsibility of the program should be outside the wall. Okay, I'm going to give you the details later. This is just the introduction. Okay, so that's a use case diagram. Okay, basically you need the wall, and when I talk of wall, it's really a rectangle, and then that sets the boundary at what this application should include, what the program should not include. Okay, so that is user case diagram. Any questions on that? you delimit what is should be included, what is not included in the application, which is so important. Otherwise, the whole project will never finish, because you could always add new things to it, and then you will never be able to finish. So you want to know this ahead of time, so you know when the program is going to end. You don't want an open-ended project, it will never end. Kind of like this one we're doing. Okay, second diagram is the class diagram. Class diagram is made of classes. Okay, classes. Each class is a rectangle, and each class is not. When I say classes, actually is not accurate. That also include interfaces as well. Okay, so interface is considered to be a special class, which with all the methods abstract, right? So so a maybe a class diagram. Let me do it again. Class diagram is made of classes, and each class, which including interface, is made of a rectangle again, and most importantly is the relationship between classes are represented by lines. Okay, and the lines could be dotted line, dashed line, could be solid line, and with arrows. Okay, the arrows indicating what exactly the relationship is, if there's any. Remember we talked about it like owns, has a relationship, owns a relationship, is a relationship. Do you remember is a relationship when we talk about inheritance? Right? A student is a person, a dog is a pet, a dog is an animal, a cat is an animal, right? That's called is a relationship, right? Is a relationship means inheritance, correct? Yes, it's inheritance. So that's all represented by how the connector between rectangles, what kind of arrow you use, what kind of line you use. So in general, class diagram is the collection of classes, and also the relationships between the classes by using of various kinds of lines and arrows. Now, with those two diagrams, I mean, then you should be able to tell what are the functionality of the program, what it does, and also how this program is built, and what classes are there. And in the rectangle, you explain what variables are there, what methods are there. You don't have to implement them though. There's no coding at all. Don't forget, we're not going to get in coding until very late. So right now, there's no coding still. So don't submit a coding, okay? Don't just show me the program, how beautiful it is. At this point, I don't care. Just show me the PDF diagram. Good? All right, any questions? Yes, Jalio.
I believe that there are some programs that let you create from scratch the UML diagram. Do you
Yes.
recommend any of the most known ones to you? Which one do you
Well,
recommend?
you can use many, the hundreds probably out there, because it's such a big thing. There are thousands of books on your UML diagrams, but there are two we use in the past, free, user-friendly, I think user-friendly. One's called a Violet UML. Violet UML, I think it's the Violet UML. You can search that, see if there's, I think it's Violet UML, if I remember correctly. Okay, that's one you can use. Another one is called, UMLlet. Let me see. God, I'm so old. Let me see. UMLlet. Yeah, UML. Yeah, it is UML. Okay, so let me just do the second one, the first one. UML violet. UML. Yeah, that's correct. Okay, that's correct. Okay, so I was right. So the two ones go to violet. Okay, purple, violet, purple, rose is red. Okay, so violet UML. Another one is going to UML ET, and there's another one. So these are the two free, been around for a long time. And then if you Google it, there's a lot of more, thousands more you can use. Usually there's a drag and drop, you can do it. And then there's another thing you can do, which I don't recommend. That is because that defeats our purpose. You can write the whole code in Eclipse. You can implement the whole application. And then you can click a button in UML in Eclipse that will turn your code into a UML diagram for you. That's reverse engineering. That's what not I want you to do. You understand? That's another one. I want you to go the other way. I want you to do the UML, do the design, do the thinking before generate the code, rather than finish the coding and then click the button, and Eclipse will allow you to will generate the UML based on the code you write. Okay, all right. And there is another IDE which also has this functionality, which we don't use, but another campus uses called Blue J. You heard of that? Blue J is another IDE. Now, as you write the code, as you write each class, it generates UML for you. Okay, so as you write each class, and as you code, and one class has an object of another class, for example, say person class has an address, right? So the Blue J will actually create the UML and show you what it looks like, and then show you the lines, connectors, show you the rectangles, show you the variables, show you the methods. It's all based on what you write in Blue J. Okay, again, that's just put the cart in front of the horse. So I don't want you to do that. Okay, so I want you not writing code, instead use some programs one way or another to generate UML, and then you will then convert them into PDF file, and then put them into your project folder. Remember the project folder for this project? And then when you push it to the GitHub, they will go to the GitHub as well. Because GitHub does not just take code, it takes everything, any type of files. You can put your videos, your movies, your music, song, you can all push onto the GitHub. It takes any kind of files, including PDF, of course. But I don't want to put all the videos in there, okay? Music. For your project, just put whatever we need for the project. So UML diagram should go there. So that's another commit, at least one commit. So hopefully as you finish each diagram, like user case, you're going to push it in as one commit and put a message, added user case diagram, and then finish the class diagram, you put another commit, you push, and then you say finished or added a class diagram. Okay, so that's the assignment. Okay, any questions on that? If not, then we're going to look at those two diagrams and we're going to explain to you what they mean and how they are built, okay? So we'll get into details. Good? All right, so I'm going to show you the examples of these diagrams. So let me see. I will go to a site called a UML diagram. Underscore, I think it's underscore diagram. There's so many of them. Yes. Okay. It's called uml-diagrams.org. So here is the link. There are tons of these such websites on this topic. The one I use is called uml-diagrams.org. So this is the one thing you can look at it. You can also watch YouTube videos for that. And then, okay. So UML stands for Unified Modeling Language, right? It's a standard visual modeling language intended to be used for modeling business and similar processes, analysis, design, and implementation of software-based systems. So it's used widely in business and in programming. So it's a standard visual. Don't forget that visual. So it's for you to visually present some ideas, your ideas, without writing a line of code. Okay, so you can read about the history, you can read about different versions, there are a bunch of diagram makers, there's advertisement, lucid chart. So there's tons, thousands of those, but I don't want you to get all carried away. So I want you just use the user case diagram. This is the one we're gonna look up. Okay, that's the first one. And the second one is called a class diagrams, which should be under your UML here, class diagrams. You see that? So class diagrams is here and user case diagrams here. So there are tens of different diagrams. It gets pretty complicated. There are big fat books on them, but I just want to get a taste of it. Just look at the use case diagram and a class diagram. Okay, here's use case diagram. Use case diagram defines the responsibility of the application. In other words, what this program does. Okay, so I can show you one example. Here is a use case diagram. Okay, remember it has a wall. The wall in this case is a rectangle. So you must always have a rectangle because that sets the boundary. And you can read this, this kind of color, what kind of color this is? Orange. Okay, orange kind of color. This kind of things that is not part of the diagram, by the way. So when you do your UML diagram, you don't need to put this in. Okay, this is just like explanation, illustration. So all you need is everything else without this orange type of letters, okay, or words. So here is the boundary, and you can call this subject or business boundary. Okay, everything inside of this rectangle means what this program is going to do, and that's the responsibility of the program. Everything outside is not the responsibility of the application of your program. Okay, so that's why it sets the limitation, sets the boundary. Okay, now each of this, okay, is a use case. Each of the oval is a use case. Okay, you notice there's no code in there. You just have a couple words. Okay, like this one, it says group check-in. In other words, this defines a use case, a function, so to speak, so people can do group check-in. This is the airport, by the way. I should have mentioned that. Okay, so this is an application for airport usage. Okay, so airport allows group check-in. You see this? Okay, without saying anything in specific, you just say function-wise, this program covers group check-in. Okay, so it's the oval. And this also does another use case called the individual check-in. You see that? That's responsibility as well. Okay, and then you have another one, so the baggage check-in, and finally you have a security screening. So this whole airport business application has 4 use cases. Okay. So now there's no specifics. This all has 1 or 2 words to specify what this does. Okay, that's all it does with the oval inside the boundary. And now you see a bunch of lines, right? You see the lines. Okay, some with arrows, some without arrows. You see that, right? So those are relationships. Those reflect relationships between these use cases. Okay, now let's take a look at the outside the 2 stick figures first. Okay, we call them actors. See, this is one actor, this is another actor. Okay, now this actor has a name, is called a tour guide. Okay, another one is called a passenger. Okay, so now you see the relationship between the tour guide and the passenger. You see there's a solid line, right? Solid line. And then you see there is a arrow. The arrow is empty, first of all. Okay, but it's closed. Okay, see, this is the arrow is open. This is not closed. You see there's no horizontal line. So this is the open arrow. This is the closed, empty arrow. Okay, it has the meaning. This means generalization between actors. Generalization means this is a general case of this one. So the arrow is pointing to the general case. General case is a passenger. So which means a tour guide is a more general passenger. So is a relationship. So tour guide is a passenger. Why? Because tour guide can travel too, right? They can be passenger. Like a student is a person. Okay, so that tells you whenever you see generalization means inheritance. So that means this particular symbol, a solid line with a empty closed arrowhead, that means a inheritance. So if you do this, you give this diagram to someone, a developer, they know you want this to be inheritance. They know that a passenger is a superclass, a tour guide is a subclass. Okay, that's all contributed by that line, solid line, and then arrow, that particular arrow. That's called generalization. In or inheritance in programming. But if you say inheritance to business people, they have no idea. So that's why UML gives another set of name called generalization, because it's meant for other people to understand, like a business people, because they use UML as well. Okay, if just used for programmers, this is really means inheritance. But more generally in UML language, we call it generalization. Does that make sense? All right, good. All right. So we are not responsible for them. Obviously, someone's going to generate the business actor, right? Passenger, the username, the password, passport ID, passport number, those things, I don't care. That's not my responsibility, in other words. Okay, someone may have to generate a class for passengers, someone may have to generate a class for tour guide, but since it's outside the rectangle, so the airport application does not do that. So someone has to do that and feed an object of the tour guide or object of a passenger to your airport program, in other words. Or hire someone else or pay someone else to do those classes. It's not responsibility, okay? Now, this solid line without arrow, right? You see the tour guide and the group checking, it's just a solid line, represent a very loose relationship. And the most loose or loosest, I don't know if that's the correct word, is called association. Association is a tour guide, the users, group check-in, and they're related. The two things are related. The tour guide is related to group check-in. That's it. It doesn't say anything more than that. So very, very general. Okay, it's not saying whether group checking has a tour guide or not, or owns a tour guide or no, or is a tour guide, no. You just say the two things somehow they relate, they are associated. Doesn't lose the relationship. This is just the different from no relationship. Okay, of course you can have no relationship because passengers don't do group checking. You see that? There's no line in between them, those two. That means passengers individually do not do group check-in. Okay, so there's no line. That means no relationship whatsoever. But tour guide is associated with the group check-in. That's all they try to convey. Okay, that's all it does try to convey. All right. By the way, if you have your UML diagram, you can do it in Eclipse by adding a add-on or a little sub-program into Eclipse. You can go to the market, the Eclipse market, and you can add a add-on to your Eclipse, and then you can draw your UML diagram as well. And you can go look at the YouTube, and then the people showing how to do it. Okay, now if you do it in your Eclipse, when you're done, you click a button, you will write the code for you. You don't have to separate write your code. That shows you how tight the code is to the related to UML diagram. It goes vice versa. If you finish UML, you can produce the code for you. If you produce the code, Eclipse can convert it back to UML. Okay, but I don't want you to do it because that gives you a chance to try to write the code and try to do the traditional way. I want you to unlearn that, get into the habit, do the design first, think about relationship between classes, think about efficiency before you write a code, before you write one line of code. Okay, but you can do it. You can do it in Eclipse. You can do it in any other IDE as well. So now we're talking about two kinds of relationship, right? One is association. This is association, by the way. Okay, this is association. This is association. This is association. Solid line, no arrows. Just say they are related. Okay. Now, there are this thing over here. One dot star. Okay. Okay. So this is called a multiplicity. Multiplicity, the line says multiplicity. Okay, what that means is, let's look at this one first. Okay, this one has none. This one, the first one has none, just associated, right? That means one when we have no number, no multiplicity mark, by default means one. Okay, that means one group check-in module can do one tour guide. Okay, one group check-in instance can do one tour guide at a time. You can only deal with one tour guide at a time. The software module you're writing, this function you're writing or method, whatever, you can only deal with one instance of each, can do one tour guide each time at the same time. Okay, now this one, when you do individual check-in, okay, the one individual check-in can check in one or multiple passengers. So sometimes you go to the airport check-in desk, you see a whole family walk up to the desk. You've seen those? You've seen those, right? No? You never try with the family. When you try with the whole family walk up to the desk and then put all the bags right onto the belt, and then you can ask, oh, can we all sit together? Or if you hate each other, can we sit away from each other? That's the place you make a request. You don't remember that? Maybe you have a small family or something, but that's what it means. That means each individual check-in module you write is able to deal with one or more passengers. So when you design your check-in, say, method or your class, whatever, how you design, there's no indication how it's implemented though, because we're not up to that point yet, right? So that means the module, one instance module can check in one or more individual passengers at a time. So that functionality is included in the application. Okay, so one, that means one, dot, okay, then star means many, star means many, one or many. Okay, so that's that one. This one is just more explicit. It says one, security screening checks one or more people at a time. Okay, that, you go to the airport, you see that a bunch of people there, some with checking your bag, some will yelling at you, say, hurry up, put your laptop out, put your laptop out, right? Take off your shoes. So there's multiple people there and then working on multiple passengers at the same time. So that's what it shows. That's what it is. Okay, so you allow that. So if you write your program can only check in or screen one passenger, that means this is not implemented correctly. Okay, so that's why such a diagram is such a detail, gives you such a detail. So it is something that you can make everybody understand because it can be so specific. Okay, or the programs understand, or the owner of the airport, they know what you are contributing, what your program can do, just by looking at this without knowing, by looking at the diagram without knowing a line of Java. Okay, here is a dashed line, right? And then with the empty open arrowhead. Okay, it's open because this is not closed here. You see, there's no line here. Same thing here. Okay, that's a type of relationship, is a dashed line, by the way. And then you have two angle brackets up here, and one says extend, one says include. Okay, include means it's required. So that means the group check-in also include a individual check-in. So in other words, the group check-in module includes a individual check-in module. It's required. You have to have an individual check-in. In other words, you cannot have a group check-in that's group only. You have to be able to do individual check-in. Okay, so that's include. Include means it's required, it's absolutely needed. As opposed to extend relationship means it's optional. Okay, in other words, when you do individual check-in, it's optional to have a batch check-in or not. In other words, whoever does individual check-in may do a batch check-in or may not do a batch check-in. So that module does not require a batch check-in module inside. Not everybody needs to do a batch check-in. In other words, when you travel light, you have no batch to check in, then you can just don't do it. You don't have to do batch check-in. Okay, so that's what the extend mean. Okay, yeah, that's it. And then it also shows there's no relationship between batch check-in or individual check-in with the security screening, because that's a totally different module, totally independent. There's no relationship between security screening and everything else in here. See, there's no line whatsoever, which is good, right? Because you don't want those people to get mixed up with other people because they're important. Security check-in, right? Usually they outsource to another company, right? They're terrible people in general. So that's the one simple example of a group of a user case diagram. right? It shows there are 4 user cases. In other words, the program has 4 functions. Has 4 functions. Okay, that's 4 things, in other words. Okay, so your project, you need such a diagram. Okay, you need to have some kind of actor as well. Okay, if you want to add some actors, you can add, or if you, since our case though, our users are inside, so they're not outside. Don't forget that. Our users are inside the rectangle. We are responsible for the user. So that means the wall should expand to include this. And if there's no external user at all, in other words, there's no other things needed outside of our application, it seems to be the case, right? Because we don't need any other actors, right? When we create our own applications, it's self-contained, totally independent. So we don't have anybody, no actors outside, in other words. We don't have actors. Everything we do is inside. It's our responsibility, it's self-contained. Okay, now if I can give you an example, sometimes we might, right? For example, if we want to incorporate things like when you do a trail, you have those shelters, hostels, hotels, restaurants, all those rest stops. And if you don't do those and you want them to be included in your application, so those will be actors. By the way, actors do not mean people. That do not necessarily mean people. They mean things that is outside your responsibility. That's what it is. They mean things you don't create, you don't write your code for, that we call actors. They're not always the people. Okay, I'll give you another example. I think here, there's another example. Okay, this is a checkout. Checkout of what? It didn't check. It didn't say what it checked out. Okay, it's a subsystem just checkout. Okay, so by the way, you could do the whole thing into one use case diagram. Okay, like this is a whole entire user case diagram, right? You can also break it down into multiple. If the application is complicated, okay, it will be too crowded to put everything into one diagram. Then you can break it down into subsystems. Like in this case, this is the one subsystem for checkout. Of some kind of I don't know what kind of checkout. Could it be library? Could it be like a retail? I don't know. It doesn't care. It doesn't matter, right? Okay, here you have customers. Those are actors, you see, and associated with the checkout. Okay, now there's a clerk. Is also an actor that also associated with the checkout. Okay, now checkout has a optional, you see, extend help module. So in other words, a customer can optionally seek help or without seeking help. See that? So that's the extend relationship, right? And the checkout must have a payment module. In other words, in order to finish checkout, you must do payment. You have to pay. Okay, so it has a user case called payment, and then payment is related to another actor. It's called a payment service. It's a bank, so to speak, or credit card charging company. Okay, so that is also an actor, even though it's not a person. It's a bank. It's not a person, but it's still called an actor. And the relationship is you could each time the payment service can charge nobody or charge many people. So 0 ... many. Okay. Now administrators of the application can manage users. See, that's the relationship. Manage users. Clerk manages the checkout, and I guess that's it. That's another simple user case. Okay, so the point is that a actor does not have to be a person. That's the point. Okay, so now your job, I know time is up. Your job is to create a use case diagram like this and get to know some kind of UML diagram maker program, and then try to draw such diagram for your application. In other words, you want to see what modules you should have without getting into details of how to write those modules. Okay, good. Okay, so I think that's it for the day. And then, unless you have any questions, otherwise I see you on Wednesday. And then Wednesday, we're going to talk about the other diagrams called the class diagram. And then next Monday, a week from today, you're going to do 2 diagrams, put into your project, and then upload to your GitHub. Make sure you check your GitHub, make sure I add it as a collaborator so I can see your project. I'm not going to change anything, just can see it. I accept that whoever I receive, from whom I received the invitation. So if you don't see me, that means I didn't get the invitation, okay? Any questions? No? All right, I see you on Wednesday. Adios.
Have a good day, Professor.
Bye.